Lesson B2 Exterior Angles of Triangle. First, we're going to look at an applet. So here we have triangles ABC. The red angle and the green angle both represents two interior angles in this triangle. And if we try to move these angles to a new position, let's see what happens. We notice that these two interior angles add up to the exterior angles on the opposite side, next to angle C. Well, what if we change this triangle? Will this relationship still work? So let's say I move angle A here and change angle B up like that. Let's see. So move the red angle and the green angle. They still add up to the opposite exterior angles. So in fact, this is actually called the exterior angles of triangles. So in a triangle, if I locate two interior angles, A and B, and then extend the bottom side to reach point D, we have angle E, which is called an exterior angle. And the angles A and B are called the opposite interior angles of angle E. And we can say that the exterior angle of a triangle is equal to the sum of the two opposite interior angles, or A plus B is equal to E in this case. So let's use this relationship to solve a few questions. So 1A. Here 73 degrees and 45 degrees are interior angles opposite from X. So we can find the size of X by adding 73 and 45 degrees, which is 118 degrees. In question 1B, we have two unknown angles A and B. So here I can see that angle A is right next to 120 degrees and they form a straight line. Or we can say that they are supplementary angles that add up to 180 degrees. Therefore, angle A is 180 minus 120, which is 60 degrees. So now we're going to label 60 degrees beside angle A and look for a relationship to solve for angle B. Well, earlier we just learned that if I know two interior angles in a triangle, I will be able to calculate the size of its exterior angle. So I can also say in here then, A plus B is equal to 135. So it's like working backwards now because we are looking for one of these two interior angles, but we know the sum. So we can say angle B is 135, take away 60, and therefore its size is 75 degrees. How do we construct exterior angles of a triangle? You always make sure you extend each side in the same direction. So here are two examples. So I'm starting from the top left corner here in the triangle. I start drawing and extending the line to the right. So now we go clockwise, so we follow the direction of a clock. The second side here, we start from the corner or the vertex and keep extending it. And then for the third side, extend it this way. So we're always making a right turn, so to speak. And what do you notice? Well, the first exterior angle plus the second exterior angle plus the third exterior angle. Once we complete all these walks, it looks like we have completed a circle. We can also construct exterior angles by rotating counterclockwise. So, for example, if I start from the bottom right corner here, I go to the left, and now I start going to my left, So here is another exterior angle. Go to the left. I have, well, right, but you're making a left turn. So now this is an exterior angle. Okay, so once again, it looks like we have walked a full circle. And what we can also say that is that the sum of three exterior angles of a triangle is 360 degrees because we're making a full turn. With this relationship, if we look at the following example, I have 128 degrees, angle E, and 105 degrees. These three exterior angles will add up to 360 degrees. 128 plus 105 is 233 degrees, plus E is 360. To find the size of angle E, I subtract 233 from 360. That will give me 127. Question B. Here, if you look at the markings on the triangle, it tells me that all three sides of this triangle are equal. We call this type of triangle an equilateral triangle. Angle A is one of the interior angles in this equilateral triangle. But we know all three angles in an equilateral triangle are the same, so I can also label these other two angles angle A. And we know that 3A, or 3 times A, or A plus A, will add up to 180 degrees. To find angle A, I just divide 180 by 3, so angle A is 60 degrees. And this is true for any equilateral triangle, big or small, because you are always dealing with three equal angles. That causes you to divide 180 degrees by 3. And now how about angle E? Well, angle E is outside of this triangle, so it is an exterior angle. Again, because this is an equilateral triangle, this also implies all three exterior angles are equal. So we know that E plus E plus E, or 3E, is equal to 360 degrees. So E can be found by dividing 360 by 3, which is 120 degrees. Can you think of a different way to find angle E? Well, take a look at angle A and angle E. Because we have already calculated angle A to be 60 degrees, and these two angles form 180 degrees. A different way to find angle E, therefore, is to subtract 60 degrees from 180 degrees, which will also give you 120 degrees. So I hope you have gotten a clearer understanding about the relationship between interior angles and exterior angle in a triangle, and also had the opportunity to review the fact that the three angles inside a triangle will add up to 180 degrees. That's the end of this lesson. You can now do some practice questions.